This is the largest commercial passive house project in the UK, and not just the largest by a small amount, it's the largest by a long way.
So the Centre for Medicine's a £28.5 million project for the University of Leicester, and some of the green design features that we're incorporating are a green wall, we've got a green roof, there's triple glazing on the project. Okay, so a lot of the money is being spent on the mechanical and electrical package on the project, and that is due to the nature of the passive house.
Passive house is a German concept. This is one of the first office block buildings outside of mainland Europe that has been designed to passive house standards. In Germany you'll get large office blocks all the way down to small residential homes that work on this principle. The basic concept is the building uses as little energy as possible. This building will use approximately 1/10 of the energy that a building regs compliant building will normally use.
The university need to lower their carbon targets, and from consultation with their designers, they were really keen to push the passive house standard. Wilmot Dixon have done passive house projects previously, so it was an obvious choice that we were asked to be on the tender list for them. It's a 6-storey concrete frame building. It's going to house around 3,000 students, all learning to be future doctors, so it's a fantastic building for the future, not just from the energy side, but what it's giving back to the country in terms of student education.
To make this work, we've incorporated a number of features into the design. We have super insulation. Even the pile caps underneath the building that we're sat on are covered in insulation. All the walls are super insulated and the roof is super insulated. We have every piece of glazing in the building is triple glazed. We have every coal bridge on the project is thermally modelled by specialist engineers. And where we can, we omit these and design them out. But a good example, what everybody will probably understand, is a stainless steel brick tie. A stainless steel brick tie will allow heat to come from the warm side of the building to the outside, so it's a channel for losing heat. We're using carbon fibre ties here, which do not allow the heat to escape outside the building.
Got an air tightness rating of 1, which is well below current building standards. We've also got renewables such as PVs up on the roofs, and we've got a ground to air heat recovery system. So we're currently 6-7 metres down in the basement. This is the main plant room of the building. It will house most of the air handling units, but you can see the size of the plant room behind me. The reason it's so large is partly to do with the ground-to-air heat recovery system and the large ducts that come into the plant room. The ground-to-air heat recovery system utilises a network of underground pipes, essentially, which sit underneath the footprint of the building. The idea of these is it takes the air externally and either heats or cools it to a constant temperature. The ground is at a constant temperature of 14 degrees. So as an example, if the outside air temperature was -5, the air would arrive at our air handling units at 14 degrees. So it's had some free heat given to it from the ground, reducing the energy put into it to raise the temperature.
From a personal perspective, one of the things I've been thinking about with this building is the onward use of it. Typically when you put a building up, you see that's a fantastic building, it's finished, and you don't really give much thought to what's happening in that building afterwards. This building's training doctors and medics that will be saving our respective lives in the near future.
I love doing technically challenging buildings, and this is very technically challenging, so it ticks all those boxes for me personally. It's also great to see a building that's at the forefront of what we're doing in the industry at the moment. The benefits in the future for the university are huge, and it's buildings like this that are going to help make big steps forwards to reduce those carbon targets. Wilmot Dixon have completed a number of Passive House projects in the past. We're also founder members of the Passive House Institute, so we take the standard very seriously. It also meets our sustainable agenda, and looking forward to the future, I think Passive House is going to be a huge part of the industry, which Wilmot Dixon are taking a forward-thinking role on.
This is the future of building. With the sustainability demands at the moment and government legislation and energy shortages, all buildings in the future will be like this. Give it 10 years or 20 years, they will all be built to this standard.